Okay, today's topic is going to be taken from MAC 1105 College Algebra, and the topic for today is the average rate of change of a function. My name's Kurt Overhiser, and I'll be your host as we look at a couple examples and as we try to understand this concept of average rate of change. So, we'll start off with an example. And we are going to find the average rate of change of the function y equals x squared minus 4x minus 5 from x equals 2 to x equals 5. And the first step is we need to get a corresponding y values for the two x values that we have. We have one x value of 2 and a second x value of 5. So what we need to do is to plug in. So we'll call this x1 and then this x2. So let's figure out what y1 is. So we have to take 2 and plug it into our function. 2 squared minus 4 times 2 minus 5 equals negative 9. And then y2, we're going to plug 5 into our function. So we get 5 squared minus 4 times 5 minus 5 equals 0. And so what we end up having is we have 2 points. We have 2 comma negative 9. And then 5 comma 0. 2 is x1, negative 9 is y1, 5 is x2, and then 0 is y2. So with these 2 points, when we see the average rate of change, what that means is we need to find the slope. So we've got 2 points, and so we're going to find the slope between those two numbers. So there's a formula for slope. It's y2 minus y1 over x2 minus x1. So we get 0 minus a negative 9. Be careful of double negative. And we're going to divide that by 5 minus 2. So you get 9 divided by 3, which is 3. That is the final answer. 3 is the average rate of change of the function from x equals 2 to x equals 5. So you take your x values, plug them into the function to get corresponding y values, and then as a result you get 2 points that you find the slope between, and that's your average rate of change. So we're going to look at some notation right here. Slope, as you know, is the change in y over the change in x. And the formula we just said was y2 minus y1 over x2 minus x1. And then if you might remember when you were introduced to functions, we were always told that y will always be equal to f of x, right there. This is anytime we see the variable y, we always assume that y is a function of x in calculus and college algebra. So what this means is you can, when we say y2 and y1, like we had up there, y2 must be equal to f of x2, and then y1 must be equal to f of x1. Okay, 2, 2, 1, 1, they have to correspond, the numbers. So we're going to go back up to the slope equation up here, and we're going to set this equal to, when we see y2, y2 is equal to f of x2, then minus f of x1 divided by x2 minus x1. And that is the formulation. This right here is the function notation for the average rate of change of your function between x1 and x2. So now we're going to go to our second example, and we're going to use the example. We're going to use one of the 8 basic functions that you might be familiar with. One of the 8 basic functions says f of x equals 1 over x, which is the reciprocal function. And for this function, we're going to find the average rate of change between x equals 0.5 and x equals 3. So we're going to use the formula that we have starred right here, that we boxed in, and x1 will be 0.5 and x2 will be 3. So when we start with the formula, f of x2 minus f of x1 divided by x2 minus x1. And so we get, since x2 is 3, we get f of 3 minus f of 0.5 divided by 3 minus 0.5. Okay, so with the reciprocal function, we take the reciprocal of 3, which is 1/3, and subtract the reciprocal of 0.5, and then take that whole thing divided by 3 minus 0.5. So we get 1/3 minus 2 divided by 2.5. So 1/3 minus 2 is a negative 5/3, and we're going to divide that by 2.5, which is 5/2. And then when we divide two fractions, we have to multiply the numerator by the reciprocal of the denominator, so we get negative 5/3 times, we take negative 5/3 and we multiply it by the reciprocal of 5/2, which is 2/5, and so we get negative 2/3 is the average rate of change, and that will be our answer right there. So we're done. Okay, so that is how you find the average rate of change of any function, is by using that formula that I have starred. So hopefully that helps and you understand a little bit better the function notation, and good luck in your studies. Bye-bye.